Hello everyone, welcome back. If you're new here, we've been making an asteroid style game using composition, showing how composition is a great way to make your projects scalable. We started with Godot 4.4 and have now migrated to Godot 4.5. In this video, we'll be adding an explore mode to the game. We will look at the Camera2D node and some of its features. We will also look at refactoring the move ability to handle the explore movement and refactor the asteroid movement and shot movement also so that it knows when to use the wraparound code or the limit code. I would really like to say a big thanks to all of you that have shown your support to the project by your likes, views, comments, and questions. Just like this great comment from Dark Souls 3333. I hope I got that right. I don't know if one of your videos already shows this, but if there's a tutorial on how to make this game screen not fixed, and more so lets you have a big space area to explore, and the camera follows the ship around. Not only that, but the camera doesn't just snap to the character, but lags behind a bit, like there's inertia the camera has to overcome, kinda like the ship's acceleration and deceleration. I would like the camera to act that way as well once you get outside a certain radius that's around the center of the screen, so that the camera only moves to follow the player as they get towards the edges of the screen. Well, that's way outside the scope of this current Asteroids game, but this is also a great way to show the power and flexibility of using composition, and maybe you can find a way to integrate this new mode into this example project, or when making your own games. We'll have to make a lot of changes, but the great part is that we won't have to break our current project. We can just add a new game mode called Explore Mode, add a camera to the player, add the new explore movement ability to the player, and also make some changes to the asteroid spawner, and single shot. Let's get started. First, let's duplicate the game mode and call it Explore Mode. With the root node selected, we can add a node 2D and call it Background Holder. We will use this node to hold all the backgrounds that we will use because I want to easily see the ship's movement across the level. Next, we add a sprite 2D as a child of the BG holder and drag in the sprite that we will use into the texture rect in the inspector. I made this background white so that we can easily change its color. Then we simply duplicate the sprite 2D a few times and rename them to top left, top right, bottom left, and bottom right. Let's quickly take a look at the project settings. Remember the viewport width and height was set to 960 by 540? Well, I chose that size because it's half of 1920 by 1080. So now in the inspector we can change the position of the top right position to 960, the bottom left position to 540, and the top right to 960 on the X and 540 on the Y. Now, I would like to reduce the alpha of all these sprites. We could do it individually, but here's a cool tip. If we select the background holder node 2D, we can change the alpha of all its children by going to the inspector and change the modulate alpha value, which will change the value of the alpha for all its children. And now we can change the color of the top left and bottom right sprites using its self-modulate value. I will make it a cool teal color. Oh, and before I forget, let's rename the root node to Explore Game. Now let's turn our attention to the player. We can right click and make the player scene local. This will expose all its nodes in the current scene tree. Now let's rename the player ship to Player Ship Explore. I explained the use of making local in part 3 of the series when we were making the asteroids. It's a really cool shortcut when you want to quickly duplicate a scene and keep all its elements. So check out that video if you want a more in-depth look. Now let's keep the project organized. It's beginning to get a lot bigger than I anticipated. We can make a new folder called Player and bring the player ship into this folder, and also save this player ship Explore branch as scene in this player folder. Now let's open the player ship Explore scene and start making some changes. The first change I want to make is remove the wraparound function. from the move ability, because in the move ability that Dark Souls 3333 suggested, the player should just be able to explore the level and not wrap back around to the other side of the screen. So let's duplicate the move ability and call it explore move ability. Then open it to make some changes. First, we can copy the move ability script, since we'll be reusing a big part of it. Then remove this script and rename the root node to explore move ability and create a new script called explore move ability and paste in the move ability script. And now for some refactoring. We can remove the wraparound logic and add the explore move scene as a child of the abilities node and assign the player and player sprite. And just as expected, the player moves, but the wraparound function is gone. In order to be able to follow the player along the level, we can add a camera that follows the player. And the easiest way to do this is to add a camera as a child of the player. We can add a node 2D, call it camera holder, and then add a Camera2D node as a child of the camera holder and call it player explore camera. The Camera2D node is robust, feature-rich, and really easy to set up. And the best part of all the features are built right in the inspector. We can adjust things like the zoom, the camera limits that stops the camera from moving when reaching the scroll limits, or position smoothing that smoothly moves the camera's view towards the target's position, or the drag that makes the camera only move when reaching the edges of the screen. So the size of the play area is 1920 by 1080. To add this to the limits of the camera in the inspector, we can set the left limit and top limit to be 0. Next, the right limit to be 1920 and the bottom limit to be 1080. Now, when we play the game, we can see that we can freely move around the screen and the camera follows the player. But this camera follows the player very closely. So to change that, we can add position smoothing and change the speed to around 2.5 and also increase the drag margins to 0.6. Now, when we play the scene, we can see a big difference in the way the camera moves. But the player can still go off screen. So let's take a look at the Explore Movability script. I won't go into great detail about how the player movability was created, because I went through that thoroughly in part 1 of the series, but here's a quick overview. This script handles the player's rotation, forward and backward movement, acceleration and deceleration. It reads input actions like forward, reverse, turn left and turn right, then applies thrust or rotation to the player's velocity. The player's sprite animation also changes depending on whether the player is moving forward or idle. The script limits the maximum speed, applies gradual slowing when no input is pressed, and ensures the player moves smoothly in any direction. However, in the original version of the script, the player's position was wrapped around the screen using the wrapped F function. This meant that when the player moved beyond the edge of the screen, they would reappear on the opposite side, like in a classic Asteroid style game. In this updated version, that behavior has been changed to use clamp instead. By using clamp, the player's position is now restricted to stay within the visible screen area. Specifically this line, player.globalPosition equal player.globalPosition.clamp vector 2 0 screen size. This line ensures that the player's position never goes below 0 0 or beyond the maximum screen size 1920 by 1080. So in simpler terms, instead of wrapping around the edges, the player now collides with the screen borders and can't move off screen. This makes sense for our new exploration-based movement, where the player is meant to stay within this defined area rather than looping around the playfield. Now, in the ready function, we will set the game mode in the game manager to be Explore. We need to do this so that the game is aware that the Explore mode has started. Not to worry, this will all make sense right now. In the Game Manager Autoload, we need to make some additions so that the game takes into consideration the new Explore game mode. These updates allow the rest of the game, especially newly spawned in objects like the player, the shot, and the asteroids, to recognize which mode is currently active and adjust their behavior accordingly. First, we add a variable to store the current mode. This acts as a global reference that any script can access to check the current game state. For instance, the single shot script can use this value to decide whether wrap shot should be enabled or disabled when it's created. But more on that later. Finally, we add a new function to handle the mode transition. Function start explore mode. Current mode equal explore. When this function is called, it updates the current mode to explore. This ensures that both existing and newly spawned nodes are aware that the game has entered explore mode and can adjust their logic appropriately. In short, these additions make the game manager more flexible and event-driven, providing a clean and centralized way to manage game modes and communicate those changes through the project. Now that we have the player all set up, we'll need to do some refactoring to the single shot script. This script controls how the shot behaves once it spawns. It extends Area 2D, which means it can detect collisions and move freely in 2D space. The script begins by exporting a few key variables. Speed determines how fast the projectile travels. Lifetime controls how long it stays active before disappearing. And now, wrap shot, a new Boolean toggle that declares whether the projectile wraps around the screen edges or not. By default, wrap shot is set to true, meaning that bullets will behave like the classic Asteroid game. If they go off one side of the screen, they'll reappear on the opposite side. However, inside the ready function, we check the current game mode using the game manager. If GameManager.currentMode is equal to explore, then wrap shot is equal false. This allows the bullet's behavior to change dynamically depending on the mode. When the player is in explore mode, wrapping is disabled, so bullets no longer loop around the edges of the screen. They simply travel straight ahead until their lifetime runs out. During initialization, the script also calculates the bullet's direction and velocity based on its rotation, ensuring it moves in the exact direction it was fired. A timer is created using createTimer to automatically remove the bullet after its lifetime expires, preventing old projectiles from building up and affecting performance. In the physics process delta function, the bullet updates its position each frame according to its velocity and the frame's delta time. The wrap shot variable then determines which movement rule applies. If wrap shot is true, the script uses wrap F to make the bullet reappear on the opposite side of the screen once it crosses an edge. If wrap shot is false, the bullet simply moves forward and disappears naturally when its lifetime ends. This small addition makes the script more versatile and mode aware, allowing a single projectile system to adapt seamlessly between different gameplay styles. And this change can also be made to the multi-shot and tri-shot abilities, so that they can be used in the explore mode as well. Now for the asteroids. Technically, we could leave the asteroids movement script the same, and have the asteroids wrap around. But this would mean that they would only wrap correctly within the top left portion of the gameplay area, causing some undesired behavior. So let's fix that by integrating the game manager's new mode system. The key change here is that we now check the current game mode stored in the game manager autoload to determine how the asteroid should behave. If GameManager.currentMode is equal to explore, then useWrapF equals false. This simple addition ties the asteroid logic directly to the game's active mode, which stores the current gameplay state. By reading that variable, this script can automatically adjust how the asteroids behave without needing manual setup or separate versions for each mode. When the game is in explore mode, useWrap is set to false, meaning the asteroids no longer loop around the screen. Instead, they move freely until they exit the defined play area, at which point they are removed from the scene using Q3. This helps maintain a more contained and realistic environment for exploration gameplay. In all other modes, such as roguelike or arcade mode, use wrap remains true, allowing asteroids to continuously wrap around the screen edges, the traditional behavior that fits the asteroids looping gameplay. With that done, we need to change the spawn positions of the asteroids. And to do this is really simple. We can simply duplicate the Infinite Spawner scene and rename it to Infinite Spawner Explore, and reposition the marker 2D nodes to accommodate the new play area. Then finally, add a new button to the game mode screen called Explore and connect an on-press signal to the modes menu script that changes the scene to the Explore mode scene. And there you have it. We've added the new Explore mode to the game using a Camera2D node. Thanks for joining me in this series. And as always, if you like what you saw so far, why not subscribe and give the video a like? This really helps me to get this video out to those who may really need it. And turn on notifications so you can join me for future updates. And while you're here, why not check out one of my other videos, like one of these on screen right now? Or you know what? I'd love to hear what you think of the series so far. Until next time, happy coding, and I'll see you in the comments. This has been Diragu Games.